Hello my friends, welcome again to my video channel. Today we will continue our work on the Kenwood TS130S. First topic is cleaning the relay contacts. We have seen in the first video that there is obviously a problem also in the relay contacts in the switching. So let's start with the relays. In this transceiver there are totally 3 relays. One is on the RF-IF board. This is for switching between receive and transmit, to switch between the use of the filters and other stages. RID switching is also made with this relay. A second relay we cannot see here is on the filter board. I have to open it. This is the RX-TX relay, which switches the antenna input and is also used for switching the information for the S meter, whether the RF or the ALC or the S meter, the receive strength is indicated. This relay is located here. And the third relay we have, where is it? We have here this one. This is the attenuator relay, to switch the attenuator on off. I will also clean it. In the last video we have seen that the switching of the instrument of the meter is a little bit difficult, not as it should, between ALC, IC collector current and RF indication in the case of a receive. So maybe the switch still has a problem, or the relay. First I will focus on the relay, and maybe there's also a modification here on the remote output. I have seen in the manual someone noticed that there's also 13 volt fed out. Same modification as on the microphone connector. Wouldn't be nice. I check this and the relay, so I have to remove first the PA and the filter unit. To get access to the filter unit, it's only necessary to remove 6 screws. 1, 2, 3, 4 and 5 and 6. So we can flip out this unit. This is a PA brick. Here we have the filter. The switch also needs cleaning. Here's a relay which I have to clean. It's a little bit difficult. Maybe I can skip off the plastic cover without breaking it. Otherwise it would be necessary to take out the whole unit. And now I see another modification. And obviously there is no limit regarding nonsense. In the manual it was indicated that the auxiliary output, which is here, not for the remote VFO, it's the auxiliary output, has 12 volt applied to a free pin, not used pin. This is this red wire. This red wire goes to the pin where we have the 13 volt. There is absolutely no fuse. Okay, we can say this thin wire is a fuse. Imagine we have here a power supply connected, 13 volt, at least 30 amps, and the short circuit current, short circuit capability may be higher, much bigger than 30 amps. Whenever we have a short circuit in the auxiliary connections anywhere where this 12 volt is used, there's flowing a current of 30 amps or more. Okay, again, this wire could be a fuse, but I think it's not a good idea. This is nonsense to do this. Whenever you use such a voltage here with how high power capability, use at least a fuse or any other current limitation. I will remove this. It's not necessary. It's my first job now. And while I'm waiting for the soldering iron getting hot, that's the indication of the modification. Pin 7, that's the remote connector. Remote connector, we have here pin 7 plus 13.8 volt. Wow. I unplugged these connectors, and luckily I could remove the cover of the relay rather easy with a dentist tool. So I could take it away, flip it off. But now I have the problem that I have no direct access to the contacts. The contacts are under this movement here, so I cannot use any paper to squeeze it between the contacts. So I can only use some contact cleaner, spray it in, and use a contact wash to remove the cleaner, and then I can only hope that it's okay. All other things would require to take out the board, maybe unsolder the relay. This is not so nice, so I don't do it, and I hope it's okay. I use some paper to soak up the cleaner to avoid any additional damage in the circuit, in the boards, in the surrounding boards. My attempts to clean the relay were not successful. I still have the problem with bad contacts. I have to take out the whole unit. It's not so difficult. There are screws in the corners. I can take it out. And here I have another problem. This is only one part of the switch, of the band switch. The other one is behind this metal shield. I can't have any access to it, so I have to take out also this switch. As I understand, it's sufficient to loosen these two nuts here, and then I can take out the whole unit together with the board and flip it out, hopefully, because I don't see any other connections. Maybe I have to unplug some wires, but in general it should be possible. This is unfortunately not screwed. No, it is fixed, soldered. Well, but it's not difficult. I will take out the whole unit, flip it out, and then I have access to the relay. Better access, I can clean the contacts easier, and the second switch behind this one. Yes, well, thinking is one thing, doing is another thing. I can't do this work as I have thought because the screw here is not fixed on the back side. When I rotate the nut, the screw also rotates. So I have to take out the whole unit. And this means I have to loosen this nut. And then I can flip out, hopefully, the whole unit. And of course, these two screws, fixing screws or set screws, have to be opened also. Now the whole unit is out. I only had to unplug these 4 plugs. They are located here. The rest can be taken out now easily. I have good access to the switch. And now also to the relay, to the contacts from the side. I can check them and clean them as necessary. A knob makes it much easier to rotate the switch. Then we can use such cotton sticks or similar. Squeeze it in and rotate the knob. Or sometimes I use paper. I use a paper wrapped around a tweezer, which I can hold into the switch and then rotate the switch. And it also takes away the oxide. Of course, use a little bit contact cleaner. Repeat this procedure until the contacts are shiny. And then I think we are on the safe side now. And now we can clean the contacts of the relay. The normal closed, the normal open relays. Small strip of blotting paper, 2 millimeters approximately. And we see there is still some dirt which comes out. So the contacts are not clean. The procedure using alone a spray contact cleaner is not sufficient. The normal open, simply squeeze down the contacts, then you can clean it same way. And always use 1 or 2 drops of contact cleaner. Now a small hint when reinstalling the whole unit again. It is reinstalled, all screws are fixed, the cover of the relay is back. This mechanism here has a trap. These contacts, here we see the wiper contact. One moment. Here we have the wiper, and this is a tap, a contact which rotates from this pin to this and so on. And this has to be exactly centered. That means the distance here to the other contact and here to the other contact should be the same, as close as possible. Here we have a detent position. We cannot align too much, but it's a question of the position of the screws and the nuts, so that this position is okay. But we have a problem when we are not precise enough with the other contacts. Here we have the coupler between the switch with the detent positions and the other contacts, and this coupler has not a precise position. It has to be aligned rather carefully. When we have the small wrench in, we can move it, and we see that there is also a contact which rotates from pin to pin, and we have, I'll show it a little bit better. And here we have to look for the same topic, that the contact from here and here has the same distance to the neighboring contact. And you'll see when I rotate it, then this pin is not precisely adjusted. Also have a look here and here, so that all three pins are completely in line, synchronized with the main contact. When squeezing the screws and then fixing them, we have to be careful. And the other one, and the second one also, second screw has to be fixed. And watch the contacts that they don't move when fixing the screws. Take a lamp and check the contacts that they are correctly aligned. And after some adjusting and tweaking these screws, 4 screws in this coupler, 2 in another 2, look that there is a flat portion, so the screw should be as vertical, as straight as possible. The other one is not so critical from the side. Well, carefully check the position of the contacts again, that it is in line in the detent position, that it's okay all over the whole band setting ranges. There are 2 additional relays. One relay, this small relay, is to switch on or off the attenuator. That's the RF signal from the antenna. It is attenuated here or not, it's decided by this little relay. It's a single pole changeover contact. This is the output which goes to the front end. And the second relay is this one. It's on the IF board. It switches some functions between receive and transmit, for example a read function, or what is it, different amplifiers for RX or TX mode, ALC and such things. Now a first check of the receiver sensitivity. I've tuned in a signal of 28.100 megahertz. I didn't choose 28.00 because at the 0 frequency there is an internal beat frequency. I don't know exactly where it comes from. It is not from the signal generator. and disconnected. No change, so I assume it's an internal signal. So I have chosen 100. This is a signal 0.25 microvolt, which should be, I think, 10 dB or so. Signal plus noise to noise. This is SSB bandwidth, and when I go to 1.8 kilohertz and in CW narrow, hope you can hear it. Okay, seems to work, but the S meter has to be recalibrated, because when I choose a signal 50 microvolt, one moment, this is 50 microvolt now. There is no S meter deflection. The attenuator works, but the S meter does not react. Maybe there is a misalignment. I have the feeling that all pots have to be reset, or maybe the pots are also dirty and need some cleaning. And now I see there is a problem with the S meter. The RF gain was fully clockwise as it should be. When I turn it down, the S meter jumps in steps. I cannot tune it linearly. It steps. It reacts in steps only. That's not good. And when I detune it, there is something wrong. Maybe the time constant of the ALC causes a problem. I go to CW. There is no option to switch the time constant. It is switched, I assume, with the mode switch. Oh, this looks like a problem in the ALC circuit of the receive path. I have the same effect on another band, 20 meter band, same behavior. This is minimum RF gain. When I increase it, and I don't believe that it is the meter. Don't think there's a mechanical problem with the meter, because the meter moves. And also in transmit mode it reacted as I've seen. So I'm quite sure it's a problem in the ALC circuit. Did I really say that I assume there is no mechanical problem with the S meter or with this meter in general? Did I check it up to now? No. Let's check it. I have a circuit connected to the plus pole of the receiver. The receiver is dead, no connection to power. Between the plus pole, the meter is connected to plus 13.8 volt on one side, and the other side is connected to the circuit, which is related to the 13 volt. I have here a series resistor. It's 22K. The current goes through this instrument, 1 milliamp full scale, and then I look for the switch on the ALC IC switch for the pin where the meter is connected. I hope I get it. Wrong side? Wrong pin, sorry. First pin. And now we see we have a linear movement here and also here. The meter seems to be okay. Full scale is 0.5 milliamp, a little bit less. But obviously we have no problems with the meter. It's really okay. It moves as it should. Okay, it's bottom side up or top side down, but I think this should have an influence on it. Should have. Now I'm operating it in a different position. Again, it works as it should. Smooth, linear, no problem. So I can say the meter is okay mechanically, and the problem is indeed in the ALC or AGC circuit anywhere else. With this check of the meter, we are at the end of part 2. At the end of part 2 I have more work to do than at the end of part 1. I thought in part 2 I can finalize this project, cleaning contacts, checking some alignment points, and then close the case. But in part 3 I have to check for the ALC and AGC circuit, for both receive and transmit. And I found another modification in the range of the loudspeaker and earphone connections. There are some wires, or one wire is cut off, another wire is missing. Don't know exactly what the reason is. In the manual I found a sketch for another modification, which I think is obviously not made, or it is removed. Meanwhile, someone tried to put in a settable output power with a potentiometer. I'm not quite sure what is done, what is realized and not. So you see a lot of work in part 3, but now again part 2 is ended. Stay tuned, stay healthy, see you on this channel.